Hello everyone, my name is Brad Erickson. I'm the director for the Mayo AI Lab at Mayo Clinic, and I'm going to talk today about hyperautomation for high-volume AI. I want to say thank you to the organizers of this meeting for allowing me to speak today. I wish I could be there in person, but unfortunately the other obligations kept me from being there, but I hope to see you all again in the near future. I do have some conflicts of interest. Anytime I'm speaking something close to the topic, I will point those out to you. Radiology has a strong tradition of being highly innovative. We've always led the digital transformations in healthcare, whether it's CT scanners, MR scanners, or if you think about how we recorded our information. For 100 years, we had paper and film, but then about 30 years ago, we started to transition to where the images were digital, as were our reports. I think we now need to start to prepare for the next important innovation, and that's process automation. Now, what you say, what is that doing in a meeting all about AI? And I'm well aware of the fact that AI is improving the care of our patients, whether it's automated detection of certain diseases, automated measurement of certain diseases, improving the way that we interpret images is clearly something that AI can help us with. But a problem is that these technologies are not so great. And in fact, more than 5 years ago, there was a prediction that in 5 years, AI was going to do better than us and that we would be replaced. We all know that we're still doing our work pretty much like we used to be doing, and this prediction didn't come true. And why is that? Well, today's AI is really pretty limited. They typically do very narrow tasks. By that I mean that, for instance, an algorithm that is designed to detect hemorrhage on a head CT will not find hemorrhage in other body parts. It will not find hemorrhage on MRI, and it will not detect brain tumors or other pathologies. It can do that one task and that one task only. Furthermore, as far as I know, every FDA-cleared AI tool in radiology is unimodal. And by that I mean it focuses only on pixels. So it will take one set of pixels, make a prediction, and that's it. Now, how many radiologists would be comfortable ignoring the history, ignoring what's going on with the patient, and looking only at the images to make a diagnosis? In some cases that could work, but the vast majority of radiology requires the integration of multiple image sets and multiple non-image data in order to make the best diagnosis. In fact, Dr. Mohammed Shura, the CEO of Paxera, said that 10,000 AI tools will be required to cover the diagnostic tasks of a radiologist, and that's because each AI tool is so narrow in what it can do. So let's think about that. 10,000 AI tools. Now, let's say that maybe 10% apply to a given examination, and let's say somehow they're good enough so that we can threshold out 90% of those. In other words, 10% of those AI tools would have something that's relevant. That means we would still have 100 AI results that we need to wade through. If each one of those 100 requires 10 seconds, that's 1,000 seconds, or nearly 17 minutes per examination. Now, I don't know about you, but I definitely do not have 17 minutes of extra time to go through all these AI results. And since they're unimodal, they don't compare the prior examination, and so that's still got to be done. So the amount of savings is really pretty minimal and probably results more in a cost. And even more disappointing is that they don't perform very well, particularly as time passes. This happens to be the report of one commercially cleared tool for doing cervical spine fracture, and you can see that in this instance, they found it was only about 55% sensitive. But let's look at this from a different perspective. Let's look at it from the infrastructure perspective. Let's say that a given hospital has only 100 AI tools. How would you put that into practice? Option number one, we could have 100 buttons on each scanner. The tech would then send the images to all the AI tools that they think are relevant. Option number two, Every scanner sends to all 100 AI tools, and the tool runs when the tool thinks that it's relevant. Now, you might be able to have a router that could filter out some of the series. For instance, maybe it takes only the axial, so all the coronal and sagittal reformats in the case of a CT might work. But when you get to MR and you try to figure out, well, what's a T1 and what's a T1 that's relevant, that becomes a much more complex task. A third option is that the PACS could have 100 buttons for each AI tool, one button for each AI tool, and therefore 100 buttons, and the radiologist would click on the ones that they want to use, and then of course they'd have to wait for the results. And at least I don't know about you, but on my PACS, there's hardly space for the 10 or 15 buttons that I use that are not related to AI. I can't imagine how I would go through 100 buttons, let alone wait for the results of 100 different AI tools. And then the fourth option is that we have some sort of platform that sends the right series or exams, as well as the non-DICOM data, to the right tools at the right time, collects the results, and also might perhaps do the follow-up of that AI tool to make sure that its performance continues to do well. So let's think about that option a little bit more. That means that such an AI platform would have to be multimodal, and that means it would have to handle multiple series in the case of MRI, multiple examinations so that you can do a comparison with the prior, and you need to be able to handle multiple information types. For instance, collect the important lab tests, medications, and clinical history. And so that really makes the current filter and forward technologies or DICOM routers really untenable as an AI platform. I think also it requires that we automate performance monitoring. If you have 100 tools out there, you can't afford to have humans go and track down the results of each AI prediction and compare that with what actually happened. But it's critical that you do that. You need to be able to watch for drift in performance because it's well known that drift is common. And so you need to determine if predictions are reliable. I think also it should promote the low-risk incremental conversion of human tasks to AI. There are many steps in the care process of patients that are susceptible or great candidates for being replaced by AI. And that then means that our limited human resources can be applied to those tasks that really do need to be human. So really, next generation AI requires a next generation infrastructure. So the dream is that we have these AI tools and we're going to go dancing down the yellow brick road to the Emerald City and everything will be hunky-dory. It seems like it's such a straightforward thing. But I think in reality, we're really on a much more rickety path where right now we have direct sends from DICOM scanners to AI tools, but that is just not a realistic option, particularly if we want more sophisticated AI tools. And so I think we really need to go back to the future. So let's think about what I mean when I say this. And what I mean is that early AI tools were rule-based systems. They were effective and they were understandable to humans. And so the first one that I'm aware of in healthcare was a system called Mycin that was actually developed by Ted Shortliff, among others, and one of the publications was in 1975, although was developed over several years in the early 70s. And essentially, they had about 500 rules that implemented this system and recommended what the likely antimicrobial agent should be for treating an infection. And so this really maps onto what is known as process automation. So process automation is technology to automate complex business processes, and it brings three values. First of all, it reliably executes business and care processes. It reliably collects and centralizes operational information, and it reduces human effort. And it does this by using a text description of the process which is executed by an engine. So essentially, this is very much like that rule-based system of Mycin. So let's examine each of these a little bit more closely. So the first one, to automate processes. Now, in most cases, the automation is accomplished using a workflow engine. And workflows can be created graphically and then converted into that program known as Business Process Model Notation, or BPMN, which is executed by the workflow engine. And so at the bottom, then you see a typical graphical description of such a process. It looks kind of like a Visio diagram, and that's because there's a lot of overlap, right? Visio is about describing a process, and so are these. So why would you want to use a commercial workflow engine? Well, there's several advantages. First of all, it has tools that allow you to graphically create the text description of the workflow. And I think that just like how we tend to have bugs more frequently in programs that are created by text compared to graphical languages like, say, Logo, it has a lot of advantages for developing bugless workflow descriptions, as well as having everybody understand what the workflow is. They are also highly reliable. These have been used and developed for years. They're highly scalable, and they are interoperable. They know how to communicate via standards. So I would have you just do a quick thought experiment when so many vendors say, well, we have our own workflow system. And let me have you think about, well, would you also then trust them to write their own database? Why do you use a commercial database? Pretty much the same reasons, right? Reliability, scalability, interoperability. We should expect the same of workflow systems. And so I really would encourage you to think about using commercial workflow engines, not home-built systems. Second, they help you collect and centralize operational information. One feature of workflow engines is that each and every event is logged and the operations data is available via a dashboard. So that means that when you implement some new step in your process, you don't have to go back to a vendor of a dashboard system and have them build a new interface or something. All the information is there. So dashboards are another common component of these workflow systems because they're built to optimize your care, not just execute it. And third, it can reduce human effort. Many steps in healthcare are currently performed by doctors, nurses, techs, or patients that involve recollecting information that's already in a system. If we had a workflow system that was kind of working in parallel, it could grab that information and tee it up for the human so that they don't have to go into the EMR in order to find it. And so that can reduce effort, reduce frustration, delays, and ultimately burnout. And that's critical. I don't know how it is at your hospital, but in our hospital, we have a serious shortage of people, particularly technologists, and we have to solve this problem in a smarter way. So, just an example of what a workflow looks like. This is what MR scheduling could look like, where you have an event coming in here, and then you have these boxes that represent steps along the way. These diamond shapes are where decisions are made, and I'm going to delve into these a little bit more closely. So if we look at MR scheduling, I'll look at that a little bit more in detail lately. So I think that process automation is really required for healthcare. And there are some premises that I think lead me to that conclusion. First of all, I think that there's going to be an ecosystem of many AI tools in the clinical environment, and we need some platform that's going to tie them all together. I think it's undesirable to have individuals decide and execute each tool that's going to be applied in each study, because that results in variability and delays in care process. And I think that the information required by AI tools is going to increase in volume and complexity. And again, humans cannot be expected to pick up that slack. I think process automation in radiology is optimal because there are predefined criteria that will determine the AIs and non-AI steps that should be applied in each patient care process. I think these can be integrated using existing informatics standards, things like DICOM, HL7, and FHIR. And I think this is going to be the most cost-effective over the long term. Now, again, I want to remind you of the conflict of interest in that one of my companies is focused on this. But again, I'm not saying this all as a lonely voice. There are several other sources. For instance, this is from Gartner that said that in the next decade, more than 50% of the interactions will be automated through process automation. This also means that healthcare providers that don't keep up with industry trends will face financial downfall. Gartner is obviously familiar with industries outside of healthcare, and they've seen how process automation is making substantial improvements in both the quality as well as the efficiency of processes. And they're saying that this has got to happen in healthcare as well. And in fact, there is a connection between process automation and artificial intelligence. Process automation allows you to define care processes, but it also can collect a lot of information required for training an AI tool and ultimately then also for executing an AI tool. And so while machine learning is great for many tasks, in many cases, you don't want to have a machine learn the bad workflows. And so this is again why having a system that is based on rules where you define this is how I want it to be, as opposed to this is how it is critical for advancing and improving how we care for patients. So again, I want to reiterate, I think next generation AI requires next generation infrastructure, and I'm going to say it needs hyperautomation. So what the heck is hyperautomation? According to Gartner again, hyperautomation involves the orchestrated use of multiple technologies, including AI, machine learning, event-driven software architecture, robotic process automation, business process management, and intelligent business process management. In other words, hyperautomation is where you combine the traditional rule-type process automation with components that do deep learning, the AI that we always think about. So where is healthcare on the adoption of hyperautomation? And while we have fairly broad adoption of process automation in the back office, there is almost no adoption, or I would say there is no adoption of process automation in patient care. Why is that? I think there are a few reasons, and I'm actually going to reflect on Mayo's experience in adopting hyperautomation technology. And kind of the baby step of this was 10 years ago when we implemented a system for brain tumor change detection. And this system required 4 series from both a current and a prior MRI examination of the brain. And when my postdoc developed this system, we sent it out there and we trained the technologists and the desk people how to collect the images and send it to the server that we had. We had it set up so that the technologists would send the current images from the MR scanner, and the desk people were responsible for pulling the old examination out of the PACS archive and sending it to the server. And yet we were still missing a large number of examinations, and that's because we heard the radiologists complain that they weren't seeing the results. And we looked at the number of cases that were processed, and we knew that there were a lot more than around 10 or 15 per week. And so that's really what drove our first foray into this hyperautomation technology and workflow engines. And so we built a system that would listen to the scanners and recognize when one of these examinations was being performed, and it would then grab all the images for the current exam. It would also do a query against the archive and get the images for the old examination, package those up, send them to this change detection system, grab the results, and send them to the web server where the results were viewed. And you can see that in the week where we implemented this process automation system, the number of cases that were processed by the server about quadrupled. So it does have a clear impact on both quality, but also now it means we didn't expect the techs or desk people to do this manual process of finding exams and sending them to the server. Since that time, we've implemented several other tools into the clinical practice. For CT, we do CT denoising on 122 CT scanners across our enterprise. We run body composition on every abdominal CT with the appropriate acquisition. We also do a number of 3D lab tasks, for instance, rendering of the carotids in the case of CTA, also a number of orthopedic applications for rendering bones. In the case of MRI, we do total kidney volume and total liver volume in patients that have concern for polycystic kidney or polycystic liver disease. We do brain glioma genomics, aneurysm detection, and most recently, liver metastasis volumetrics. And so we have a fairly long track record now of implementing HyperAutomation for executing AI tools in our clinical practice. And here you can see both the cumulative number of inferences, and this is excluding CT denoising. That is kind of so straightforward that I didn't consider that counted. But you can see that we are now having surpassed about 200,000 cumulative inferences, and we're now doing almost 80,000 yearly inferences with this system. And where are we going? Well, one of the next tools that we implement will be a multimodal AI tool for glioma follow-ups to try to differentiate true progression from pseudoprogression. So this is a workflow that requires the current examination and prior examination, just like the change detection system, but it also requires the radiation treatment plan to know where the isodose contours were. It requires temozolomide, steroid, MGMT methylation information, and all that gets packaged up and sent off to the AI tool. And out of the AI tool, then, we get predictions like, for instance, a 0.62% chance that the patient is stable with an expected survival of 2.2 years, 11% chance that there's regression, 7% chance of progression, and then there's a component of uncertainty. So let's walk a little bit closer into that example of doing multimodal glioma response. So as I mentioned, we listened to the output of all the scanners. So we received DICOM images, and we look to see whether there's an axial dynamic susceptibility contrast series. And if there isn't, we exit out. This sequence is unique to glioma follow-ups, so if it's present, we know that this is a glioma follow-up and something that we should try to run our AI tool on. So we collect all those images for that current examination, and then this symbol here means that you start to do steps in parallel. So in parallel, we get information about the patient age and gender. We also get information about the medications, and this little symbol here says, if you don't get the results in a certain amount of time, then do this step. And in this case, we just assume that there's no change in medications. It's the best you can do if the information isn't there, right? We also try to go out and get the RT plan. And again, if it's not available, then we'll just live without it. And then we try to get the prior examination. Now, in that case, if we don't get it, the AI tool is not worthwhile. And so we just record that and we exit out of this workflow. This step means collect all the results from these parallel steps, and then we register images to the T1 post-contrast image. If that fails, we exit out after notifying the appropriate people. If we are successful, we execute the glioma AI. Again, if there's a failure, we record it, exit. If there are positive results, we then send that to the radiologist and they decide, should this be included in the medical record? We don't want garbage in the medical record. This is kind of a policy thing we do. If we say yes, include it, we send the results to the PACS and the electronic health record. But in either case, we save the results for subsequent follow-up. So this is a little bit more detailed step into what these workflow diagrams look like. And you can see that there are different symbols up here. Most of these are gears. That means that it's an automated task, but this means this is a human task. This would be an email task. But I also want to emphasize that hyperautomation can help with non-AI tasks. So let's think about the scheduling process. And at the start, we might be 100% human performed. So here we start we get a HL7 order that's received. And let's focus in on MR for right now. So we're going to, first of all, look to see if the order is for MR. And if it's not, we exit out here. But if it is, then we're going to move on to the next step, which is where we're going to look to see if there is any MR unsafe device. So this is a little tool that we've built here where we search every medical record, including those from Care Everywhere, in other words, notes generated outside our hospital, for some key phrases, things like aneurysm clip, for instance, or pacemaker, that may reflect MR unsafe devices. And if those sentences are present, we would then show them to the human, and the human would decide whether or not an MR scan is appropriate. If those sentences aren't present, then we go straight through to the next step, which is predicting whether IV contrast is needed. And again, we've got a heuristic that is pretty good at figuring out whether IV contrast is needed. And the reason that we do that is that we don't want to find out when the patient shows up to be scanned that they have poor renal function, or that we don't know if they have bad renal function and we need to do a stat creatinine, for instance, and the scanner is sitting empty, or if they have a contrast sensitivity, maybe you want to pre-treat them in some way. Getting this information ahead of time is critical, and process automation can help with that. And so this is that whole workflow then of notifying the ordering physician to get an EGFR drawn if that is really required. And then, once you've figured out where it could be scheduled, you would have a scheduling bot that maybe presents an option to the patient of dates, and the bot would work with the patient to find an appropriate scheduling time. So this is just one way that you can incrementally replace humans with bots and improve workflow, improve efficiency, improve quality of care. So I think the steps that we need to take as we move towards hyperautomation is that we need to become familiar with process automation. We need to understand commercial grade workflow engines, and I think using them is critical. We need to be aware of the standards compliant workflow steps. So for instance, the SIM workflow initiative in medicine defined a nomenclature for workflow steps. And we need to engage the user community to assure that the workflow that's designed is optimal, not necessarily what you're doing right now. This is your chance to redesign things for the future. You should also look at areas that are ripe for implementation. Places where humans are out gathering data, usually that can be done better by a bot. Simple data analysis, things like safety checks. If you see certain phrases, or especially if you don't see key phrases, that probably means that they're safe. That's the way we humans do it. Probably computers can do this better. And performance monitoring of AI predictions is clearly an area where automation can help us. Trying to check on the true performance of all the AI predictions that are out there, we can't possibly afford having humans do that. And so this process automation tools can do that for us better. It can also help us standardize the way that we execute AI tools. Things like FHIR for non-DICOM information, using containers to execute the AI tools. And again, I want to emphasize that there is a workflow description language, and that can improve the way that we compare how your business is working compared to other hospitals. So my prediction is that over the next 5 years, I think hyperautomation will have a larger impact on the practice of radiology than deep learning. But after that, deep learning is going to take over. And I'm also aware that making predictions is easy, but being right is hard. But I do feel strongly that hyperautomation can really improve how we practice medicine. And so, we all start with these technology triggers like deep learning, and deep learning can do everything. Now maybe we're in that deep learning can't do anything. But I think that now we need to recognize that hyperautomation is really critical for enabling efficient use of deep learning. So the conclusions I want us to draw are that hyperautomation is critical for the adoption of multimodal next-generation AI in radiology. I think that hyperautomation can be incrementally implemented to assist in the automation of human tasks as well as AI tasks. And hyperautomation will promote the reliable execution of care processes and enable better business intelligence for radiology practices. Thank you for your attention. I hope that you found this helpful.